Welcome to Turn Right Machine Works. My name is Keith, and this is part 8 of the Wing It series. Now I've kind of jumped in here. This, of course, is all of my chicken scratch drawings on the plasma cam of the building of the rudders themselves. Now we're going to take sections at a time and kind of go through a couple of them to catch you up on what we are doing. During the last 7 parts to this series, I've had a couple overhead shots that were forgotten about and misplaced or just forgotten. So I wanted to go ahead and bring those into play and catch you up on everything before we progress on our videos. Now, of course, this is all the chicken scratch from the total video series and my complete job, but we're going to take a couple different parts here and we're going to bring them into play and we're going to catch you up with them right now. Alright, let's take this group of cutouts right here, and we're just copying these and we'll put them down in this area just about where they were on the table when we were cutting them. Now, that is the set of original steel cutouts to start the whole planning of the shape of the rudders. And this is how we went about cutting out that first set. Okay, we're getting ready to cut out these foil shapes right here on the table. This lower one right here is already cut out and we've test fit that and we've made some modifications, and the replacement for it is this one. Then the one below it is this one. The one below that is that one. That is the very bottom one. That is like the series here. This is the artist's interpretation of the glass over on the original blade. The original blade, you can see the straight lined area in here and the glass shape over it and the foil shape right here. The white line there, which is now the green line, is actually our NACA 64A018 foil shape, and that is the foil shape that we are incorporating into the rudder and proven to be a better stream for water flow. Alright, so what I've actually done is, you guys have seen the stem being machined, and this was the pattern for it. After we designed this, and we actually designed this pattern from the stem in this drawing, which is our own creation of creating the stem itself, taking and overlaying the foil shapes on the existing rudder, drawing at our locations that we want to go ahead and have the support. And then we created our angle that's got to be on the top and the forward leading edge there as well. So this is kind of just tilted sideways on our webs right here in the actual area, and this is somewhat of the curve that is duplicated on the rear of the original or the glass rudder that's in place now. And we'll be kind of playing with that. Also, this radius right here is the radius curving from the bottom up on the leading side there. We're kind of playing with all those things, but right now what we want to do is we want to go ahead and cut out these center supports for the skin itself, and of course the bottom one is just going to be there just to hold things together as far as our lines and stuff. But you know, that's kind of what we got going on right now. And the one thing that we did change, you see the cutout here for the 1/8 slip that we want to slide in, front and back. The rear one here was very shallow after we reduced it by the radius that we wanted to add on there. See, there's still a flat bar that comes across here, and that we have to structurally adhere the skin and the then the skin goes on the outside of that. So this thing will grow about 1/4 inch in all directions there from where we're at right now. Alright, let me get some air here, and then we're going to go ahead and get this rolling.
webs, and I'm trying to come up with the radius of the front and how it comes back here, maybe how it radiuses up the back side here, and also how it angles down on the front coming across here and how it angles down on the back side here. Then we can start building our flat sections of the ribs, and then after that our skin will come in and we'll be able to actually create our actual foil shape on the bottom, because it's going to be along the bottom, but it's got to take a curve, so it's going to be like stretching out stretching out a certain part of the web itself into a different narrower shape and longer, and the same thing in the back. So I have the outline, what I want to create on the plasma screen right here, and we're getting ready to cut out 2 pieces, and there'll be one forward on that side there that slips in just like that, and it'll curve into the rudder here, and it'll be angled over here, and then there's going to be one here that will have the rear curve come over here, join the bottom of the post, and then have the angle up here. Alright, so let's take a look at those on the screen.
Alright, for this next clip here, we're going to be cutting out the actual front and rear of the rudder support itself, and I wanted to show you how we got those shapes. Now, the original drawing of our rudder we took to the side, and that was this rudder here, and then we took it aside, and then we had it here, and then we drew this piece and this piece here. Alright, so we took this piece and this piece here and drew them to fit within our outline of the rudder itself. Incorporated a couple radiuses front and back, a pocket clearance down on this side here for a plug or a zinc, and a zinc pocket clearance here, attaching them at the rudder post top and bottom and passing through each of the webs in the center. And that's kind of how we drew it and planned it out to fit in here. Now, just a quickie view. In here you can see the center of our web. Then this is the 1/8 band that we want to weld to the web itself to create a spot welding surface for the rosette welding on the skin, and that outside layer is the 1/8 skin right there. So that is the layers to the rudder, and that's where these shapes will individually fare all the way out here. Now, of course, this outside layer is going to be 1/8 of an inch, so that's going to stop right there, and then this area is going to be filled in with weld. So any of these welds, because this is going to fare all the way out and be hand ground front and back. Alright, back to cutting out this piece and this piece here, and we're going to copy those and bring them out here. Alright, that is what we're going to be cutting out. Now, there's no sound in the video footage that I actually have for the actual screen cutting and explanation of that. That's why I'm coming back and ad-libbing that time period. And this is the cut, and these are the 2 pieces that we laid out and we were cutting on a screen. So I'll give you a quick run through of that, actually the footage of it being on the screen, and let's go check it out.
Alright, let's see if we can slip this front one out here first and slip this piece right into it. I didn't sand any of these. No, I just hope that there we go. Alright, we're a little bit long here, but we kind of expected that. Alright, now let's see if we can slip the back one in here. And this is the same story here. Actually, we're just kind of see if we can rock it in from there. Awesome. Alright, I gotta go with my tape measure because I just want to kind of see some sizes here. But that looks fantastic. That gives you a bet. I mean, it really starts to show it grows. And the reason why it grows so much is when you take 1/8 of an inch and you lay it down on top of here, it comes out to here, and then the next layer comes out and it comes out to here. And of course I got just a little bit longer in here because I wasn't quite sure where we're at yet. We can modify our drawing when we go to cut out our stainless steel parts. Okay, and then this right here, of course this gets, you know, fit in here. Okay, and that 1/4 inch comes, or that 1/8 inch comes to there, and then the next 1/8 of an inch of the skin will almost be right out there. So you can see how much material is getting eaten up just by 1/8 of an inch at that angle that it's coming into this plate. And of course this will get full welded around here, and then this rib that lays on here gets welded to there, and then this is steel. This isn't even the piece that go in there. I know it's shiny now because I cleaned it. But everything will be stainless steel on this. All grade 316 on the flat materials. Alright, that's good. I wanted to see this before I went in the house and started editing the rest of part 3. Everybody wants to see part 3 now. Alright, good night guys. Okay, now that we've got this cut, we kind of dressed the face of this here. We fired up our tracer attachment. We bring this in so we're against our pattern. We can crank in and out. Our actual carriage here kind of gives us the mid-stroke there. After that, we kind of just eyeball our pattern and our cutter right to, you know, the leading edge here. And of course, that's where we're going to touch first. So we crank this in. Alright, we set 0 here, just so that when we make a cut and we come out, we can come back to the same position here. We're running it in reverse. We just come in here until we cut. Alright, now we can go ahead and we can take what we want here, about 30 thousandths. Come back to like our 0 in there. We had forgotten. We're going to try out another. We're going to try out another insert here, and maybe see if I can get the package here. Okay, and these were Arnos, and okay, this is the positive one here. Now this is FNEX AM5025 CNGP is the letter terminology on this one. Kind of a real pretty insert. See if I can hold this up for you. Basically, we just got straight cut, so this is not a full sculpting cut test, but we do have 4 tapers that we're going to need to cut off of here. Whoop. You had one of those days where you can't quite hang on to anything? Alright, and our Allen wrench down there. Alright, good to go. You know, that was some pretty smooth cutting. Alright, I'm pretty impressed with this insert here. We're going to be trying it a little bit more, but I tell you what, it's giving me a real nice looking chip and a nice finish. Right now we're about 100 thousandths, still heavy, and I'm going to go ahead and take a couple more passes here. see when this major diameter comes out and flows with the shaft, that's when you can really tell that you have a taper being cut true with the axis of the shaft. You could have a little bit of egg-shaped or diameter difference and give you a little bit of waviness. But overall, if you're way out on your run out of your shaft in relationship to your machine surfaces, this will really fluctuate, and you'll see big time movement right here. That's real mild right there. All right. There's about 50 thousandths here, and we're just going to take a 15 aside on this one. We're paying attention to the finish as well. You know, so far the performance, I mean, I'm not really hogging off here, and I mean, this is some really nice cut here. But from my experience with my bits I normally use, I would be bragging about the performance of this bit here. And I'm going to be looking into purchasing more of this bit to use in my shop here, I believe. So we still have a lot more testing to do on this one bit here, but it's really standing up to personal preference and performance right now. Okay, I got a couple different nuts that I'm going to be playing around with on the end here that holds the coupling on. And anyway, I've got kind of a sample here. This is where the minor diameter of the taper is going to be, so that's a given. That has to be there. And we're going to go ahead and give ourselves 1 3/4 inches coming back here. About 1/4 inch for our draw, so that'll give us about 1.5 inches to play with. And we're ordering 2 jam nuts like this, or half nuts, nylocks, and we're ordering 2 fulls. And if it looks like this is not enough as far as the grip and everything else on there, we'll take the fulls and we can machine down the surface to make them as thick as we want. If we want to add a few threads to the length of our holding power, get the max out. We don't need it to be sticking way out. At first I was going to turn this like 2 inches long, and I think that's just a little bit long. So I'm going to settle for 1 3/4 inches. Now this is extra on the shaft here, on the length here, so we're going to go ahead, we're going to part this off right here. And I got the steady rest here, and the tailstock, I've put a center drill in there, so we're rigid, and I'll be able to part that off. Now we're doing it in here because, one, it's much faster, and also two, I can cut a lot more shafts with one insert than I can with a bandsaw blade. This Aquaman material is pretty hard on bandsaw blades. Alright, and we don't need any feed right now, but we need some RPM. got that down about 1/8 of an inch. And just by holding the pressure, we get it to break off. That way we don't end up chipping or breaking our insert. Alright, now we just switch off. We're going to go face it, and then we'll go ahead and put our center drill into the end. We'll slide it, and we're ready to start cutting on this end of the shaft. Alright, we got place pretty well cleared out here, and we're pretty well set up for putting the threads in on this one side here, and just kind of getting some of the stringier chips here out of the way. Okay. Alright, and we're good on our oils. We've already made a touch off and a test pass here. We found out that we were more so breaking inserts. We were using a new positive lead on it, and it's sucking it in. When you have a lathe with almost 60 or 70 thousandths of play in your nut, you will have tendency to suck certain things, and it took me a while to put 2 and 2 together, but that's what was happening. I was sucking the positive inserts there. These negative ones have never failed me. They are running out, or their supply is dwindling on them. I just ordered another 2 packs because they only have like 700 more available, and I'm sure there's a few more guys out there like me running the older machines, and they are proven to be a very great insert for threading. I really like them a lot. Maybe by the time I go through those, we'll pull this carriage apart, and I'll make a new cross feed screw and nut for this lathe here. So, and then then we can switch over to the positive inserts, because we won't have so much backlash in our screw here. All right, come back in here, and just since I threw it back and forth there, I'm just going to make sure that we're still zero with our material. Yep. Okay. I kind of got you up there so you can see. The thread dial is over here on this side of my machine right now. The original one used to set right over here, and I haven't made one, but there is a mount for one here, and I may make one over there. But right now what I do is I lean over here and I stare down, and when I'm ready and on my mark, then I lift it. Then I watch this. I don't have to pay attention to that to release it. You gotta pay attention to this. Okay, it comes into the relief there. Come on back, bring it in, I bring it into zero. I kind of just eyeball my dashboard gauge, okay? Now I just feed in on the compound like everybody else does, but I kind of read this right here, and this is my straight in travel, and I take 10,000 per pass till I get down to about 50 thousandths, then I break it down to 5. This is my average speed for threads on the Aquamet material. And when I'm not really, I just missed it there. When I'm not narrating my actions here, I usually can catch that number, so it can be pretty fast here. Be safe than not, especially I dug through all my inserts to find a couple that weren't broken, and they asked if I wanted to overnight my inserts, and I said, well, I got like a handful right here that I can baby or nurse. So I just said regular UPS. I'll have them in a couple days. I only got a couple jabs here to thread here for the next couple days, and anything else I don't have any problem. The Aquamet material is actually a pretty good wear. getting a rhythm. We know basically by our double depth and everything else that we got to go somewhere around 90 thousandths on the depth. And it's pretty close to 100 on this straight in because of the tool bit I'm using. And I hope that's not a sign that that bit's about ready to take a dump, but we'll see. Alright, I'm going to go ahead and flip this insert around, and we'll just go in with a spring cut for that diameter there. This side looks pretty good too. This is the beauty of being able to use inserts though, is just flipping them around and you're not losing your place in everything else here, so. It's a lot cleaner. Okay, there's your 90. Now we're going to do a spring cut. Alright, I like that. Alright, we just want to take a spring cut here. One more. Now when we're using stainless steel nuts or steel nuts on this augment material, I like to have a little bit more play, like, you know, freedom. Because they do tend, if you got them too close and you get debris and stuff in there, which hammer dings from installers and rocks and grit and all kinds of stuff like that, some of those things can really gall really fast, really simple, and real easy. And by having a little bit of clearance, more clearance than standard fit on your threads, you have less tendency, just a tiny bit of rocking on the threads, and that's good. This is a lock nut here, and we'll have nylon locking capabilities, and it will cinch up there, and that will hold really well. But the main thing is you do not want to have a nut gall on a shaft, because you end up having to usually cut the nut off and sometimes damage the shaft, and then you're throwing away thousands of dollars. Whereas just a little bit of a loose fit and some Tef gel and lubricants like that, you can keep your nuts from galling. Alright, we're going to get these set up now, and we're going to be doing some lat fitting on the tapers here before we do the cuts. One, it's much easier to wipe and clean up the compound. It's a lot easier to do draw filing to compensate for any errors that you might need, and a couple other reasons why it's great to go ahead and when you're building new shafting, to go ahead and do a preliminary lap before you start cutting your keyways.